All right, this is lesson number 38, but while we're waiting on everyone, as per usual, I'm going to give you guys a problem to work on. And so this is the problem for today. So I want y'all to go ahead and try to figure that out, okay? All right, so all Kevin, Claudia, Brianna, y'all all said the same thing. Y'all said 2, and that is actually correct. Yes, the answer is 2. It's a little tricky because you would think that the number would be a larger number, but if you start with 2, and then it says that they take half of the cakes. So if they took half, then you'll be left with 1, but then they give you back 1 cake, so then you have 2 again, and you go to each fridge and that same thing happens, and you want to end up with exactly 2 cakes, so you would need to start out with 2 cakes. So 2 is the correct answer. Yes, it's counterintuitive in a way because you wouldn't think you would start with the amount that you end with, since they're taking away half, but the half could be exactly equivalent to how much they give you back. So very good. 2 would be the correct answer. All right, awesome. So we'll go ahead and get started. This is graphing and converting polar, lesson number 38 in pre-calculus. This is a new unit separate from what we did last class, which is parametrics. Remember, in the second semester pre-cal, there's a lot of isolated topics that are all going to be what you talk about in BC calculus. These are all intros to that. We are on Wednesday, so this is specifically graphing, and we're also doing converting. And then tomorrow we'll do graphing polar equations. This is just graphing points. Tomorrow will be equations. Zoom after hours Friday if you have any questions. And then for the next 2 weeks, just for AP exams, is just time for you to work on that. And then I'll upload 1 review practice over the things that are crucial for when you start for next year AB calculus. No testing. So after that is I won't be assigning anything. I was thinking about maybe doing one end of year, I don't know, celebration in some form over Zoom, like maybe doing some kind of game or something like that, as an idea, maybe in the last 2 weeks. Ideally, I don't really like there's not really a sense of closure as we close the school year out on Zoom, obviously. But maybe something like that. It was a thought I had. Y'all can let me know what you think about that. But okay, we're going to get started. We will learn math, build character, never give up, and ask why. Okay, so let's jump into it. What is a polar graph or polar point? So we have this, which is a Cartesian coordinate plane, right? That's the regular one that we are used to, where you have an x-axis and you have a y-axis. And usually we will plot points, plot different functions, look at the relationship between 2 variables on this, right? So we're looking at, oh, excuse me, sneeze. I feel a sneeze coming. Excuse me. Excuse me. So what we're looking at today is a different type of kind of coordinate plane you can think about, and it's called a polar. So a polar coordinate plane, it looks like this, and so it has angles on it, and you have a bunch of circles, and so we're looking at how would you graph something on a polar coordinate plane versus a rectangular polar coordinate plane. Now, I meant to send this over in mine, but I had posted it on Google Classroom. I hope that you read it. There's associated with the notes, there's a explanation of when polar coordinates are used in application in real life. And if you haven't gotten the chance to read that, I do encourage you to read that. It is posted on Google Classroom. It just shows you some of the applications of polar coordinates, because we're not going to get into applications like we did with parametrics this semester. And so do take a minute, if you have not read that later on, read the polar applications PDF that I posted. It kind of shows you things like in radar or in navigation and things like that, ways in which polar coordinates are used. We're just doing strictly numbers here and angles, and so we're not getting into that. But do take a minute to read that later, because it gives you some insight into when this is used, microphones and things like that. Okay. So there is a time in which polar coordinates is more useful to look at the relationship between things than rectangular. Okay. So The rectangular coordinate system, which we're used to on the left, is just when you have x comma y is how you would label your coordinate, right? And for example, and I didn't mean to represent this as a line. We're just talking about this point right here. Okay, so this point right here is 3 comma 3. You have an x and you have a y, right? And the 0 0 is called the origin. Right, that's the middle point, the origin. That's in the rectangular coordinate system. We're very familiar with that, working with that since pre-algebra. So the polar coordinate system, which you have on the right, what this is showing you is this same point, okay, represented in the polar coordinate system. Where would it be at? Okay, so if you look at this, if you think about these values on the, it's not called the x and y axis, but let's imagine it's x and y axis. Like, let's say we place this graph and overlapped it on top of this, okay? Like you overlap that on top of this. Then this point will be in the exact same location, okay? So the location of it is not changing. It's the coordinate system we're using that's changing. Because if you look at it, if you were to try to map it right on top and you started to draw rectangular and a rectangular, and you drew your grid lines, you would notice that that point is still ending up at 3 comma 3, right? It's in the same location if we were to put the rectangular right on top of it. The polar, the way you write that, if we look at the way it's written, you have a value here and then you have an angle here. So the way the polar coordinate is written is r comma theta. R comma theta. Okay, we'll talk about what r and theta is. And 0 0 is called the pole instead of the origin. Okay, so what is r, what is theta, and what is the pole? So in the polar coordinate system, like we said, the pole is in the center, that's the pole. Then you have a polar axis, which is this is our polar axis, horizontal polar axis, vertical polar axis. So you can think about that as the x and y axis, similar to that. It's called polar axis, okay? So the pole is in the center. The r is the directed distance. The r could be positive or negative. Positive from the pole to the point, okay? So in this case, our r, this is the r. From the pole to the point, that would be the r there, okay? So the directed distance from the pole to the point is the r, okay? Then you put comma theta. Theta is the angle measurement. So this angle measurement, whatever that angle from the polar axis, the horizontal polar axis, going in the counterclockwise direction, that will give you the angle. So the directed angle from the polar axis to OP, which is from the pole to the point, okay? So if we look at this and we were thinking about that, and we're saying this is r and this is theta, what that's saying is that this is 3 square root of 2. The distance from the pole to that point is 3 square root of 2. And this angle right here is pi over 4. That's how you represent that point in the polar coordinate system. Okay. One of the reasons for that is because one of the benefits of the polar coordinate system is that you can represent a given point in multiple ways. In the rectangular system, there's only one way in which you can write the point that you have there, right? In the rectangle, you could just put it's 3 comma 3. There's no other way of writing what this point is. But if you're in the polar coordinate system, you can write this point in different ways, right? Because what we know about the unit circle is that it rotates multiple times, right? So we could write the same point and we can do 3 square root of 2, comma, and we can use the angle. We can make it go all the way around, right? We can use the angle 9 pi over 4. And that would be equivalent. That would still be the same point. So the polar coordinate system would be used when you have things that are rotating, like let's say you're talking about a bicycle wheel, or you're talking about a radar system when you're trying to find where a plane is, or things like that. You use a polar coordinate system versus a rectangular, because a rectangular one allows you to show one point. Polar shows multiple. The same point, sorry, but multiple ways, okay? All right, so let's say we wanted to graph 3 comma 60. So this is our r and this is our angle. Okay, so I like to start with the angle, which is 60 degrees. So we know 60 degrees, and this is 30, 45, 60, still written in the traditional form of the unit circle angles. So here's our angle 60. And 3 is our R. That's the distance from the pole to the point. And so if you see here, this is 1, this is 2, 3, 4, 5, like so. So if we just kind of go around the circle, 3 going around will be like to there. So this will be 3, 1, 2, 3. So this will be the point right here. 3 comma 60 would be this point right here. And that's really all there is to graphing now. So you have your angle and then you have your R, which is your directed distance. Any questions so far? Okay. All right, let's look at number 9. So let's say we wanted to graph. I'll do the first one and y'all can do the next two. So let's say we want to graph 4 comma 5 pi over 4. So again, R, this is theta. 5 pi over 4 is the angle. That's 5 45-degree angles. So remember, this is pi over 4, pi over 4, pi over 4. That's 1, 2, 3, 4, 5 pi over 4. So we know we're going to be somewhere along here. Then the R, the directed distance, is 4. So we're going to go out 4, 1, 2, 3, 4 to right here. Notice it's not like the rectangle in a sense. Usually you would think about if this was a point, you would be looking at this is negative, and then this is down is negative. It's not like that. R is just how from the pole out, how far does it go? So that would be 1, 2, 3, 4. So that's where it would be. You could also think about if you want to do the R first, right? Like this is 1, 2, 3, 4. You could start the point out here, and you could think about rotating that around to there. So if it's at positive 4, and then you're rotating it around 5 pi over 4 degrees. Okay. Now for another polar coordinate in the same position, that's just saying you could write that same exact point here. This point here, you could write it as say 4, and you could add another 2 pi, like go around again, right? So you could do 5 pi over 4 plus 2 pi. 2 pi would be another rotation, so we just put that over 1, multiply by 4 to get a common denominator. So that would be 13 pi over 4. That would be equivalent as well. 4 comma 13 pi over 4 would be in the same place because you just added 2 pi. You could also subtract 2 pi. You could do 5 pi over 4 minus 2 pi, and that would be going in the other direction. You could do the math for that, and that would give you another point. Okay. All right. Y'all go ahead and try the next two. Go ahead and try to graph those. I don't know how long it's been paused for those who were not. For those who were are watching it later. Dang it, they're not. I'm gonna go back and see how long I had it paused for. I think I had paused it when you were working on a problem at some point in the past. So I'm gonna leave this up for just give me. I'm gonna leave this up for those who are watching this later on YouTube to take a screenshot of. And then if you have questions about it, if I didn't record this part, then let me know. Send me a message on Remind. I might have to re-record a certain section, or you can ask somebody. So I'm gonna leave this up. If you're watching from YouTube, then take a screenshot of this. Let me know if you can figure out what this my handwriting means, and if you don't, let me know. Okay. Sorry. Okay, so y'all try this one that I didn't mention earlier because I don't think we had a multiple choice question. You do want to use process of elimination with these to determining what quadrant they're in. So for example, you have negative 2 commas 5 pi over 6, right? And so if you were to sketch that, you know that 5 pi over 6 is over here, 5 pi over 6, in the second quadrant. And then because it's negative 2, you're extending opposite. So we're if we were to draw circles, we would be over here, right? That's just a rough sketch of it. So because we're in the fourth quadrant, you can eliminate any answer choices which are not in the fourth quadrant. It's just a strategy when you have multiple choice. So like this isn't rectangular. That's negative, negative. So negative, negative, we're over here. So it can't be that. Over here, this is negative, positive. So negative, positive, that's up here. So it can't be that. This is positive, negative. That's over here. It could be that. This is positive, negative. That's over here. It could be that. So it could be C or D. You can eliminate kind of like that. Send a message in the chat when you're done with both of them, okay? And when you finish, you could write what you got as your answer. All right. So what I see in the chat from those who have responded is that for number 1, we got C, and for number 2, we got A. Those are both correct. Number 1 is C, and number 2 is A. On number 2, you can actually use process of elimination, determine which quadrants they're in, and the only ones that are in quadrant, the only one that is in quadrant 3 is A. And that is where, if you graph the polar, the sketch will be in that quadrant. That'll be like a shortcut. But do we have any questions about any parts of that? I'll work through whatever you need me to. But if we are all good with them, I don't need to work through all of them. Then I'll go on to the last one. But I want to make sure there are no questions. So let me pause and give you a second. If you want me to go over any part of that, any part of the problem, either one of those, let me know on the chat or via voice. So. Going once, going twice. All right. Then those are converting to rectangular. Last piece is going from rectangular to polar. So try this problem and make sure you feel comfortable with that. I'm going to work through this problem just in case if the previous part of my video was not recorded for those who are watching it on YouTube. So this is X and this is Y in the rectangular. So 2 comma -2, it's somewhere around here. And we're looking at what polar coordinate matches that. So the formula we use to find R would be the square root of x squared plus y squared. So it would be the square root of 2 squared plus -2 squared. So R would be the square root of 4 plus 4. Should be the square root of 8. When you simplify that, get a perfect square. It would be square root of 4 times square root of 2, which would be 2 square root of 2. That's your R. So we can cross out A and B. Then to find the theta is tangent inverse of y over x. So tangent inverse of -2/2. That would be -1. Tangent inverse of -1 would be when y divided by x equals -1. So that would be -1. Something you would think about your unit circle. Over here it would be a 45 because x and y has to be similar. So here's square root of 2/2 comma square root of 2/2. If you divide y divided by x there, will give you 1. Here is negative square root of 2/2 comma square root of 2/2. If you divide those, that would give you -1. Here is negative square root of 2/2 comma negative square root of 2/2. If you divide those will give you +1. Here is square root of 2/2 comma negative square root of 2/2. If you divide those will be -1. So it could be either of those angles, but I think I did something wrong. Hold on. Okay, no, that's fine. Okay, so tangent inverse -1 over -1 is -45. Okay, so we would use this one just because of the quadrant we're in with this. So -45 degrees. But we want to think about it as, so if we draw a reference angle, since we're using reference angle, we're going to say this is 45 degrees. And we're trying to find the angle from here around. So if this is 45 degrees, it's 360 minus the 45, which will give us what's in red, right? So that would be 315 degrees. And 315 degrees in radians is 7 pi over 4. So that's how we get C. Or you can just visualize where 7 pi over 4 versus 3 pi over 4 is, right? 3 pi over 4 would be in this quadrant, and then 7 pi over 4 is in the fourth quadrant. Okay, so hopefully we feel comfortable with that concept. That is an intro to graphing polar points. Tomorrow we'll do graphing polar equations. That'll be kind of connecting different points in polar. and then that'll be the last lesson of the year, and then we'll do a review after that. So um, we'll get back on tomorrow at 10. If there are no questions, you're good to log out.